Good morning, my dear student. Today we will see the concentration of solution of the solid in liquid. जैसे कि हमने लास्ट सेशन में देखा था टाइप्स ऑफ द सॉल्यूशन. Solvent may be the solid, liquid or gaseous, and solute also may be in a solid, liquid or gaseous state. Now today we will see the concentrations of solution of the solid in liquid. The concentration of solution is the amount of solute dissolved in the specific amount of solvent. Concentration is the amount of solute dissolved in a specific amount of solvent. The solution containing relatively less amount of solute are called as the dilute solution. Means according to the amount of solute dissolved in it, the solution are of the two types. One is the dilute solution, while the second is the concentrated solution. If it contains relatively more amount of solute, then the solution is called as concentrated solution. Concentrated solution. The concentration of solution may be expressed in different way. So first way to discuss the concentration is percentage by mass. First is percentage by mass. The mass of the solute in gram dissolved in solvent to form 100 gram of solution is called the percentage by mass. Definition: the mass of solute in gram dissolved in solvent to form 100 gram of solution. 100 gram of solution is called percentage by mass, and the formula percent by mass is equals to mass of solute upon mass of solution into 100. The mass of solution means the mass of solute plus mass of solvent. Okay. In this way we can determine the percentage by mass concentration of any solution. Second way to express the concentration is the percentage by volume. Second is percentage by volume. It is denoted by P by V. When both the components of the solution are in liquid phase, then determination of their precise volume is possible using the burette, pipette, specific gravity bottle or the measuring cylinder or volumetric flask, etc. Hence, in such cases, the concentration of solution may be expressed in terms of percentage by volume, and it is defined as the ratio of number of parts. You can write the definition: ratio of number of parts by volume of the solute to 100 parts by volume of the solution. Volume of the solution. We can write the formula as a percent by volume is equals to volume of solute upon volume of solution into 100. At this stage, it must be noted that the total volume of solution may not be equal to the sum of the volume of the solute and the solvent, as some of the solute particle may occupy the empty space, that is the voids present in the structure of the liquids. The volume is the temperature dependent quantity, hence the percentage by volume changes with the change in temperature. This concentration term, that is percentage by volume, changes with the change in temperature. Third way to express the concentration is mole fraction. Third way to express the concentration is mole fraction, and it is denoted by X. Mole fraction is the more scientific way to express the concentration of the components of solution. The mole fraction of any component of the solution is the ratio of number of moles of that component, number of moles of that component present in the solution to the total number of moles of all the components of the solution. For example, consider an binary solution. Consider and binary solution. बाइनरी सोल्यूशन में जो सोल्यूट है, फॉर एग्जांपल NaCl सोल्यूशन, इसमें जो सोल्यूट है वो है NaCl एंड जो सॉल्वेंट है वो है वाटर. तो जो नंबर ऑफ मोल्स ऑफ सोल्यूट है वो है N1 एंड द नंबर ऑफ मोल्स ऑफ जो सॉल्वेंट है दैट इज वाटर, इट इज N2. सो mole fraction and the mole fraction of NaCl is the X1 and the mole fraction of the water is x2. So mole fraction x1 is equals to the n1 upon n1 plus n2, or the mole fraction of the solvent, that is water, is equals to n2 upon n1 plus n2. In this way we can determine the mole fraction of any component present in the solution, and the total mole fraction, sum of the mole fractions of solvent and solute, sum of mole fractions of all component of solution is always unity, means x1 plus x2 is equal to 1. In case of the binary solution, x1 plus x2 is equal to 1. If there are the more than one solute dissolved in the solution, then x1 plus x2 plus x3 plus x4 may equals to 1, and in this way we can calculate the mole fraction of any component present in the solution. Then the fourth way to express the concentration of solution is molarity. Fourth way to express the concentration of solution is molarity. And molarity is denoted by capital M. Molarity is one of the better way of expressing the concentration of solution, and it's defined as number of moles of solute present, number of moles of solute present in 1 decimeter cube volume of solution, volume of the solution. We can write the formula as a molarity, that is denoted by capital M, is equal to number of moles of solute, number of moles of solute upon volume of solution in decimeter cube, volume of solution in decimeter cube. And number of moles means what? Number of moles अगर हमें calculate करने हैं, number of moles of any solute is equals the mass of solute in kilogram, mass of solute in kilogram upon molar mass of solute, upon molar mass of solute, यानी कि इसका molecular weight in kilogram per mole, in kilogram per mole. Molarity is expressed in moles per decimeter cube. Unit of the molarity is mole per decimeter cube. Molarity is volume dependent quantity and the volume changes with the change in temperature. Hence, the drawback of expressing the concentration in molarity is its temperature dependence. Okay. Molarity is temperature dependent quantity. Dependent quantity. Then fifth way to express the concentration is a molality. Fifth way to express the concentration is molality. Molality, and it is denoted by small m. Molality is the best as compared to the molarity, and it is defined as the number of moles of solute, dissolved in 1 kilogram of solvent. 1 kilogram of solvent. You can write the formula. Molality small m is equals to number of moles of solute upon mass of solvent in kilogram. Mass of solvent in kilogram. And molality is the temperature independent quantity, because the mass of solute does not changes with the temperature, and hence it is a temperature independent. Temperature independent quantity. Next way to express the concentration is very important, like the molarity, is the normality. Sixth one is the normality. And it is denoted by capital N. Capital N. Normality is the number of gram equivalents of substance dissolved per liter of the solution. Is the number of gram equivalents. Number of gram equivalent of substance dissolved per liter of solution. Can write the formula. Normality, it is denoted by capital N, is equals to number of gram equivalent of solute, number of gram equivalent of solute upon volume of solution in liter. Volume of solution in liter. के बाद नंबर ऑफ ग्राम इक्विवेलेंट्स कैसे डिटरमाइन करते हैं? नंबर ऑफ ग्राम इक्विवेलेंट डिटरमाइन करने के लिए हमें इक्विवेलेंट वेट डिटर्मिनेशन करना पड़ता है. सो नंबर ऑफ, ये जो क्वांटिटी है यहाँ पे नंबर ऑफ ग्राम इक्विवेलेंट्स, वो कैसे डिटरमाइन करते हैं? नंबर ऑफ ग्राम इक्विवेलेंट इज इक्वल्स टू मास ऑफ सोल्यूट इन ग्राम, mass of solute in gram upon equivalent weight of the solute. Weight of solute. इक्विवेलेंट वेट कैसे डिटरमाइन करते हैं? इक्विवेलेंट वेट ऑफ द सोल्यूट, ये जो क्वांटिटी है यहाँ पे इक्विवेलेंट वेट. सो इक्विवेलेंट वेट is equals to molecular weight upon either acidity or basicity or the valency or the change in oxidation state, change in oxidation number or number of change of electron. It depends on the species. If the species is oxidizing or reducing species, then we can divide it by the change in oxidation number. Then the acidity, if the species is a base one, then we can divide it by acidity and then basicity. Then if a salt, then valency, and from that we can determine the equivalent weight and mass of solute dissolved in the solution divided by equivalent weight. We get the number of gram equivalents. Then we can calculate the normality likewise. Then next way to express the concentration is part per million. In short we call it as a ppm. Parts per million. In short it is called as ppm. When the amount of solute in gram is present in 1 million per 1 ml of solution, the concentration of the solution is expressed in ppm, and we can calculate it as ppm concentration is equals to weight of solute in gram, weight of solute in gram upon total volume of solution in ml, total volume of solution in milliliter into 10 raised to 6 power. In case of gases, ppm refers to volumes rather than the masses, that is 1 ppm means 1 centimeter cube of gaseous components is present in 1000 liter. Then dilution law. Dilution law is very important to calculate the third solution. It we will see as the dilution law. If the molarity and the volume of solution are changed from M1V1 to M2V2, then the M1V1 is equals to the M2V2. M1V1 is equal to M2V2 is the dilution law. If two solutions of same solute are mixed, then the molarity of the resultant solution we can determine. If two solutions of the same solute are mixed, then molarity of the resultant of the resulting solution is given as as m is equal to, m is the molarity of the resultant solution. If we mix the two solution of the same solute, then m1 v1 plus m2 v2 upon v1 plus v2. By this formula we can determine the third solution's molarity, and from this first formula m1 v1 is equal to m2 v2. From this, if we dilute the solution by particular amount of the solvent, then we can calculate the molarity of the diluted solution by using the dilution law, that is m1 v1 is equal to m2 v2. तो ये था कॉन्सेंट्रेशन के रिगार्ड. इन नेक्स्ट सेशन वी विल सी द न्यूमेरिकल बेस्ड ऑन द कॉन्सेंट्रेशन टॉपिक. ऑल कॉन्सेंट्रेशन कॉन्सेप्ट विल बी क्लियर बाय द न्यूमेरिकल. सो तब तक अगर आपको मेरा वीडियो पसंद आया है तो प्लीज़ लाइक कीजिए, शेयर कीजिए एंड बेल आइकन को प्रेस कीजिए. सो व्हेनेवर आई ऐड द न्यू वीडियो यू विल गेट द नोटिफिकेशन फर्स्ट. थैंक यू सो मच.